A, B, C, D are in GP. The value of A square plus B square plus C square into B square plus C square plus D square whole divided by AB plus BC plus CD whole square is equal to how much? A, B, C, D are in GP, you have to calculate this. You can have A, say you can, okay, AR square, AR cube. Substitute in this, you are going to get A square, you can take A square common. So 1 plus R square plus R power 4. Here also A square common. R square plus R power 4 plus R power 6. Here AB, BC means you can have A square whole square means A power 4 common. 1 into R. R into R square to R cube. R square into R cube to R power 5. What's all these things will cancel. We can take out R outside. Then we can cancel with this R square. You will get 1 plus R square plus R power 4 into 1 plus R square plus R cube. You are taking R square outside. Here below what you get? 1 plus R square plus R cube whole square. Right. C square is what? R power 4, B square R square, R power 4, R power 6. R power 4 kada? R power 4. R power 4. This is that's it. A, B, C, D are in GP. Show that B minus C whole square plus C minus A whole square plus B minus D whole square. B minus C whole square plus C minus A whole square plus B minus D whole square is equal to A minus D whole square. You have to show this. Let's do the next question. See, A, B, C, D are in GP means you can have one more condition like this. AD is equal to, you can have BC. This into this is this into this. And also B square is equal to AC. C square is equal to BD. These are the conditions. You take LHS. If you take LHS, B square plus C square minus 2BC, C square plus A square minus 2AC b square plus d square minus 2bd. See, in RHS I don't want b and c. So b square is what? AC. C square is what? BD. Minus BC is what? AD. I can have AD like this. C square is what? BD. A square I want. Minus 2AC means 2b square plus b square plus d square minus bd minus 2bd like this. So what are cancellations? 2bd I want AD, isn't it? Okay. Stop this. B square P is like this you are going to get. B square is AC. AC ఉంది కదా 2AC try పెట్టేసి 2AC ఇక్కడ B square. So this is also AC. This they will cancel. Similarly C square. C square is equal to what? BD kada. Ikkada BD. So this is C square. Ivanni cancel అవుతాయి. Right. So B square 2AC. But what is BCAD? So you got directly A square plus D square minus 2A, which is equal to A minus D plus. That's it. Sigma R is equal to 1 to N 1 by R whole divided by sigma k is equal to 1 to n. K by 2n minus 2k plus 1 into 2n minus k plus 1 is equal to 2, you have to show. This is equal to 2. So this is a very interesting problem, a very much interesting problem. See, as far as the object is concerned, in order to do this type of problems, I use some value of n. See, it should be true whatever I will n value, right? So I will do like this. I will put n is equal to 2, let us say. Then what is numerator? 1 plus 1 by 2, which is 3 by 2. What is denominator? Sigma k is equal to 1 to 2. K by n is what? 2, na? So you get what? 3 minus, 5 minus 2k. Into 3 minus k. You range your k values. K is 1. 1 by 1 into 2. K is 2. 2 by 1 into 1. Equivalent to how much? 1 by 2 plus 2. 5 by 2. And is equal to 2 with k is equal to 1 to 2. K by 4 plus 1. 5 minus 2k. 4 k value is 1 by 1 into 4. K value 2 by 1 into 3. So 1 by 4 plus 2 by 3. LCM 12. 4 3s. 3 4s. So 1 by 12, 2 by 3. So 12. 1 plus 3 fourths, 8. So 9 by 12. So if you substitute, what will get? 3 by 2 by 9 by 12. 3 3s. 2 6s. 6 by 3 is 10. So if it's a multiple choice question, I give some value to n and I can verify it like this. This is the best way to type in the problem. Suppose if you want to do, it's all academic interest I am telling, if you want to do a general problem, you have to think in these lines. You call B is equal to sigma r is equal to 1 to n 1 by n. You will get 1 plus 1 by 2 up to A is equal to sigma k is equal to 1 to n. This denominator. This is your denominator. So you can dissolve into partial fractions. 1 by 2n minus 2k plus 1 minus 1 by 2n minus k plus 1 like this. This minus this is this much. Now, when you are expanding this, we start from the last term, n minus 1 up to 1. If you put n, you will get what? 1 minus. If you put n here, you will get what? 1 by n plus 1 plus n minus 1 you put. 2n minus 2n will get what? 1 by 2n minus 2n plus 2 plus 1 means 1 by 3. Now if you put here 2n minus n plus 1 plus 1. So you are going to get n plus 2. So you go on ranging it like this. Next you will get 1 by 5. Finally, when k is equal to 1, you will get 1 by n minus 1, right? K is equal to 1 with the 2n minus k is equal to 1 means 1 by 2n. And ranging from n minus 1, n minus 2 up to 1 like this. So academic interest. See how the manipulation can be done. Okay, right. B is this. So actually A comprises like this. 1 plus 1 by 3, 1 by 5, etc. etc. up to 1 by 2n minus 1 minus 1 by n plus 1, 1 by n plus 2 up to 1 by 2n like this. A and B are not like this. You consider A minus B. you consider A minus. 1 will go, 1 by 3 will go, and we will be getting minus 1 by 2. So I shall write like this, minus of 1 by 2, 1 by 4, 1 by 6. Right? Now, you are having up to 1 by 2n minus 1 is there. So 1 by 2, 1 by 6, here listen. Somewhere here what happens is, up to 1 by n all will cancel. Then here n plus 1s, some n plus 1s will cancel with this n plus 1s here. Finally you are going to get 1 by 2n. Here all odd are there. Some of the odd terms here will cancel with these odd terms here. And all even terms they will come like this. Then this is equivalent to minus 1 by 2 into 1 plus 1 by 2 up to 1 by n, which is nothing but minus b. So you have got a minus b is equal to minus b by. So a is equal to b by 2, b by a is equal to 2 units. If you want to do the problem in general, you have to do like this. See, simple multiple choice question, you need not worry about all these things. Use your common sense. It should be true for all values of n. Preferably choose n is equal to 2 or n is equal to 3, depending upon your convenience. Yes, understood? See, the next question is sigma r is equal to 1 to n tr. Tr is equal to n into 2n square plus 9n plus 30. Find sigma root of tr. R value ranges 1 to n. Sigma root of tr is how much? So this is actually your Sn. Sn is equal to this. And what is nth term? Tn is equal to Sn minus 1. So you are going to get like this. And you expand it. 2n cube plus 9n square plus 13n minus n minus 1 into 2 into n minus 1 whole square. 9 into n minus 1 plus 30. So this is 2n cube 9n square plus 13n minus. See, when you expand this, n into 2n square to 2n cube. Next is minus 4n into n. So minus 4n square plus 2n. I am just directly expanding this. Minus 1 into 2n square. Minus 2n square plus 4n minus 2 plus 9n minus 9 plus 30. This is what I am having. So what are the n squares? 9n square minus 4n square minus 2n square. So I think you will get 3n square. 3n square, right. Hence 13n minus 9 plus 4, 13, 13 plus 15n square minus 5n square plus minus half minus plus right. Then 13n, how many n's? 6 plus 9, 15 plus 2n. Right. Finally, constant how much? Plus 2n. So, this expansion you watch. N minus 1 into 2n squared minus 4n plus 2 plus 9n minus 9 plus 13. So this is minus of n into this is 2n cube. This 9n minus 4n, n minus 1 into 2n squared plus 5n, this is 15 plus 6, this is minus of 2n cube plus 5n squared plus 6n minus 2n square minus 5n minus 6. So when you simplify 2n cube, 5 minus 2 and 3, 9 minus 6 and 6n square. Then n's 6n minus 1 and n plus 12n. Next constant. Constant will be plus 6, right? So this is 6 into n plus 1 whole square. So what is your root of Tn? Root 6 into n. So what is root Tr? Root 6 into r. So sigma r is equal to 1 to n root 6 into r plus 1. So root 6 into, if you range your r values, actually sigma r plus sigma r. Root 6 into sigma r is how much? N into n plus 1 right. Sigma 1 is what? So this is your final answer. Yes, understood? So you have to first calculate Tn, which is Sn minus 1. Properly you calculate, you got Tn like this. Then root Tn you calculate, then think that, substitute. See here, r value ranges 1 to n. So sigma r plus sigma 1. Sigma r is what? R is equal to 1 to n into n plus 1 right. Sigma 1 is n, hence we can complete this problem. Yes, understood? Right. So the next question is A1, A2, A3, etc. An are in HP. A1 by A2 plus A3 plus A4 up to An. A2 by A1 plus A3 plus A4 up to An. A3 by A1 plus A2 plus A4 up to An, etc. etc. An by A1 plus A2 plus A3 up to An minus 1 are also in HP. This is what you have to show. See, first you can verify she has given n numbers. You can check it up with some 1 or 2 numbers. General proof also will do like this. 1 by A1 1 by A2, 1 by A3, 1 by AN are in AP. Multiply with A1 plus A2 plus up to AN. See, if n numbers are in AP, if you multiply with same number, still they will be in AP. This you all of you know. So when I multiply, what I will get? A1 plus A2 up to AN by A1. A1 plus A2 plus up to AN by A2. Etc. like this. A1 by A1 is 1. You will get A2 plus A3 up to A1 by A1. A2 by A2 is 1. A1 plus A3 up to AN by A2. 1 plus A1 plus A2 AN minus 1 by AN. So these are all in what? AP. You subtract 1 throughout, still they will be in AP. When these are all in AP, I mean 1 I am removing throughout, still they are in AP. So when they are in AP, their reciprocals are in what? HP. So therefore, these are all in what? HP. This is how we have to think on this problem. Otherwise, as given in terms like this, you consider some 3 terms. 1, 1 by 2, 1 by 3 you consider. So they are in what? HP. Right? Now, this is A1, this is A2, this is A3. You should write what? 1 by 2 plus 1 by 3. 1 by 2 by 1 plus 1 by 3. 1 by 3 by 1 plus 1 by 2. This is how much for you? 6 by 5. This is what? 4. 4 by 8. Correct? Sorry. 8 plus 1. This is what? 2 by 9. 6 by 5, 4 by 8, 2 by 9. Now you consider the reciprocals. 5 by 6, 1 by 2, 9 by 2. So now this minus this. 1 by 2 minus 5 by 6. LCM is what? 6. 3 minus 5. Minus 1 by 6. 9 by 2 minus 1 by 2. Just 2 3s 5 and then minus 2 by 6 minus 1 by 2. This is also same thing. So you can verify that they are in AP. Just subtract to get the answer. You can verify with 3 numbers. That's what I want to tell. Right. Find 1 cube minus 2 cube plus 3 cube minus 4 cube up to n cube, where n is odd. See, you have to find a formula for this. So you can think like this: 1 cube plus 2 cube up to n cube minus 2 into 2 cube plus 4 cube, 6 cube, etc. Since n is odd, n is, let us say, 2k plus 1. So there will be 2k plus 1 terms. So when n is 2k plus 1, what is your n minus 1? 2k. Is it not? So finally, you are going to get 2k whole cube. Right? So this is n square into n plus 1 whole square by 4 minus 2 into, you take out 2 cube outside. 1 cube, 2 cube, 3 cube up to k cube you will get. So n square into n plus 1 whole square by 4 minus 16 into k square into k plus 1 whole square by 4. So this is n square into n plus 1 whole square by 4 is a 4 fourths. So 4 into, what is k value? N minus 1 by 2 whole square into n minus 1 by 2 plus 1 whole square. So n into n plus 1 whole square by 4, 4 into n minus 1 whole square. This is what? N plus 1 whole square by 4, 4. So 4 into 4, 1, 4, 1, 4 will cancel. What is common in these two? N plus 1 whole square by 4 I can take outside. N square minus n minus 1 whole square. You can simplify this. N plus 1 whole square by 4 into 2n minus 1. Like this you can think. Right. Write on this. Largest positive term of HP whose first two terms are 2 by 5, comma 12 by 33. Largest positive term of HP whose first two terms are given like this. Is our next question. Largest positive term of HP whose first two terms are 2 by 5 and 12 by 23. See, let us say A1, A2, A3, etc. They are all in HP. A1 is equal to 2 by 5. A2 is equal to 12 by 13. So 5 by 2, 23 by 12, etc. They are in AP. I mean 1 by A3, etc. They are all in AP. You can find out common difference. D will be equivalent to 23 by 12 minus 5 by 2. So 12 is LCM. 23 minus 30 means minus 7 by 12. Minus 7 by 12. Right. So you calculate 1 by A3. 1 by A3 will be 23 by 12 minus 7 by 12. You will get how much? 16 by 12. 1 by A4. 1 by A4 is 1 by A3 minus D. So 16 by 12 minus 7 by 12. Which is how much? 11 by 12. Sorry. 9 by 12. 1 by A5. 1 by A4 minus 11 by 12. So 9 by 12 minus 6 by 12. Sorry. Minus 7 by 12. How much? 2 by 12. 1 by 6. 1 by A5. 1 by A6. 1 by A5 minus 7 by 12. So 1 by 6 minus 7 by 12. This is how much will get? 12 is LCM. So how much? This is 2 minus 7. So minus 5 by 12. So you got 1 by A1, 1 by A2 like that. So you will get 2 by 5, 12 by 23. Next what? 1 by A3, 12 by 16, 12 by 9, 6. Next minus 12 by 5. So this is the largest positive term. Among all these things, 6 is the largest positive term which are in HP. This is how you have to think on this problem. See, the next question is the sum of first n terms of the series. The sum of first n terms of the series root 3 plus root 75 plus root 243 plus root 507 up to 435 root 3. Sorry, sum of n terms is equal to 435 root 3. Find the value of n. Find the value of n. See, I can take out root 3 outside. 1 plus 5 plus 9 plus, if we divide with 3, 3 ones. So divide with 3. So 3 ones, 20 and 3 sixes, 9. So 30. Etc. is equal to 435 root 3. So root 13 into, these are all in AP, n by 2 into 2a plus n minus 1 into d is equal to this. You can cancel, you can calculate n value. I think this is quite simple, you can easily do this. Next question. A1, A2, A3, etc. they are all in AP. Such that A3 plus A7 plus A11 plus A15 is equal to 72. Then find sum of first 17 terms. Sum of first 17 terms of the series. Sum of first 17 terms of the series. You call first term as A. Common difference is equal to D. So this will be A plus 2D. A plus 6D, A plus 10D, A plus 14D is equal to this. 1, 2, 3, 4. 4A plus 8, 18, 18 plus 14, 32. D is equal to 72. Okay, right. You divide throughout with what? Let us say 2. So 2a plus 16d is equal to 36. Now, sum of the 17 terms is what? 17 by 2 into 2a plus 16d. That's why I didn't divide with 4. I have divided with what? 2 only. Keeping this in my brain. So 17 by 2 into 2a plus 16d. I think you can substitute 2a plus 16d value and you can simplify this. Hence you will get the sum of 17 terms of the series. Okay, right. Write down this question. A, B, C are positive real in AB. Such that ABC is 8. Then minimum value of B. Minimum value of B is how much? See, ABC are in positive and AP means AM greater than or equal to GM I can apply. So A plus B plus C by 3 greater than or equal to cube root of ABC. But what is A plus C to be? Because ABC are in AP. So what you are going to get? A plus C is to B means B will get. B greater than or equal to cube root of 8. How much? 2. So minimum of B is 2. That's it. Okay, right. The next question is ABC are positive. ABC are positive and 9 into 25A square plus B square plus 25 into C square minus 3AC is equal to 15B into 3A plus C. 3A plus C. Then show that BCA are in AB. You have to show that BCA are in AB. See, you can plan like this. This is 3 square 25 square means 15A whole square plus 3B whole square plus 5C whole square. Next we consider AB minus 15A into 3B minus BC you consider. BC will be 3B into 5C, 15BC minus this is 15A into 5C is equal to 0. This is just like x square plus y square plus z square minus xy minus yz minus zx is 0. See, when x, y, z are real, satisfying this condition, all of you know this implies x is equal to y is equal to z. So 15A is equal to 3B is equal to 5C. So you are going to get 5A is equal to B is equal to C. You will get like this. So 5A is equal to B is equal to 5A is equal to So 15A is equal to 3B is equal to 5C. You got it. Understood? Now you can call A is equal to K. A is equal to K by 15. B is equal to K by 3. C is equal to K by 5. We have to show what? BCA are in AB. So what is 2C? 2C is equal to 2K by what is A plus B? A plus B is equal to, sorry, C, right, K by 15, B is what? K by 3. So what is LCM? 15. K plus 5K, 6K by 15, which is 2K by 5. So I have shown A plus B is equal to 2C. Henceforth, you can think like this. Okay, right. See, the next question is sigma I is equal to 0 to infinity, j is equal to 0 to infinity, k is equal to 0 to infinity, 1 by 3 power I into 1 by 3 power j into 3 power k, I not equal to j, not equal to k. See, there is some restriction on I, j, k here. See, first what I am going to do is, I am going to calculate without any restriction on I, j, k. I ranges independently, j ranges independently, k ranges independently, like that. So you can bring 1 by 3 power I to here, 3 power j to here, 3 power k to here. See, when you calculate 1 by 3 power I is 0 to infinity, you know 1 plus 1 by 3 up to infinity, a by 1 minus r, which is 3 by 2. So this will give you 3 by 2, this will give you 3 by 2, this will give you 3 by 2. So this is equivalent to 27 by 8 you are going to get. Right. Now, this includes the cases of I is equal to j, not equal to k. J is equal to k, not equal to I. K is equal to I, not equal to j. 3 cases. And also, one more case is I is equal to j is equal to k. So these 4 cases you have to subtract. First I am going to calculate what is the value when I is equal to j. See, when I is equal to j, it becomes 1 by 9 power I into 1 by 3 power k. So when I evaluate this directly without any restriction on I and k, I am going to get what? I is equal to j. Sometimes I is equal to j is equal to k is also possible in this. So this will give you what? This you are going to get 1 by 1 minus 1 by 9. This is 1 by 1 minus 1 by 3. This is 9 by 8. This is 3 by 2. So you are going to get 27 by 16. So minus I is equal to j, case will be 27 by 16. Yes? Listen. You consider, see here I is equal to j. In this I is equal to j is equal to k also will come. Next I is equal to k case also same thing. Plus 27 by 16. Plus 27 by 16. So here I is equal to j is equal to k is involved. Here also I is equal to j is equal to k is involved. Here also I is equal to j is equal to k is involved. Apart from I is equal to j, right? Now you are expected to subtract I is equal to j is equal to k only once. But you are subtracting here, you are subtracting here, you are subtracting here. That means what? You are subtracting 3 times. But actually you are supposed to subtract what? Only once. So that's why I am going to add 2 times I is equal to j is equal to k case. So thrice I subtracted, but I am supposed to subtract what? Only once. That's why I will add twice I is equal to j is equal to k case. When I is equal to j is equal to k, I am going to get 1 by 27 to the power of I like this, which is 1 by 1 minus 1 by 27, which is 27 by 26. So 2 into 27 by 26 you will get. So this is 27 by 8 minus 3 into 27 means what? 81 by 16. 54 by 26. You can further simplify this and you will be through to your answer. This is one of the important questions, right? Okay. A1, A2, A3, AN are real numbers. Root A1, root of A2 minus 1 plus root of A3 minus 2, root of AN minus of N minus 1 is equal to 1 by 2 into A1 plus A2 plus A3 up to AN is equal to up to this. This is half into this is equal to, this is also equal to N into N minus 3 by 2. Then find sigma I is equal to 1 to 100 AN. Sigma I is equal to 1 to 100 AI. See, we will think like this. Root A1 is equal to B1. Root A2 minus 1 is equal to B2. Root AN minus of N minus 1 is Bn. See, what is A2 for you? B2 square plus 1. A1 is what? B1 square. So you will be getting a relation like this. B1 plus B2 up to Bn is equal to 1 by 2 into, I think the minus 9, right? Minus, correct. 1 by 2 into B1 square, B2 square plus 1 plus B3 square plus 2. Bn square plus n minus 1 minus n into n minus 3 by 2. Correct? I think you followed this, right? Now this is B1 plus B2 means sigma Bi is equal to, this is 1 by 2 into sigma Bi square plus n minus 1 into n by 2. N minus 1 into n by 2 minus n into n minus 3 by 2. Okay, understood? Right. So 2 sigma Bi is equal to sigma Bi square plus, see, when we simplify this, what we are going to get? N into n minus 1 by 2 minus n into n minus 3 by 2. N by 2 if I take outside, n minus 1 plus n plus 2 plus 3. So n minus n by 2 is outside, n minus 1 minus n plus 3. So we'll get 1 in right. So we get n. Actually, what I want to feel is here there is some mistake in the problem. The half will be only. This is how it should be. Then you will have like this. Then you will have a big bracket here. Like this. So just correct the problem because some mistake is there in the problem. 1 by 2 into a1 plus a2 plus a3 up to an minus n into n minus 3 by 2 will get. So as usual we can call like this. 1 by 2 into b1 square, b2 square, b3 square like this. 1 by 2 is outside. This also will have 1 by 2 outside. You simplify this. You will get what? This entire thing will become what? N. You will get like this. So when we write like this, if you bring everything onto one side, you will get sigma bi square minus 2 sigma bi plus sigma 1. N can be written as sigma 1 is equal to 0. So this is sigma bi square minus 2 bi plus 1 is 0. This is as good as sigma bi minus 1 whole square is 0. So here there are n quantities. All n quantities are what? Perfect squares. They are all positive. So sum of n quantities is 0 means each is 0. So bi is equal to 1. So from this what is the conclusion? b1 is equal to b2 is equal to b3 is equal to bn, all are 1. So that is our conclusion. So now come back to this. What is your A1? 1. What is your A2? 2. B2 square 1. 1 plus 1, 2. What is your A3? 3. What is your A50? Is what? 50. So sigma AI, I is equal to I think 1 to 50. Is 1 plus 2 plus 3 up to 50. 50 into 51 by 2 you will get. Up to 50 is that. Up to 100 means you can write up to 100 like that. You just make a correction in the problem. Just in the beginning that n into n minus 3 by 2. So you just see the problem. The problem should be like this. So there's a mistake in the problem. I think the correct problem I am once again writing. Root a1, root a2 minus 1, root an minus n minus 1 is equal to 1 by 2 into a1 plus a2 plus a3 up to an minus n into n minus 3 by 2. The problem sigma I is equal to 1 to 100 the ai. You write 100 here, you go up to 100, you will get how much? 100 into 101 by 2 you will get. That's it. Okay, I think we're all following this problem. This is a peculiar problem.